Imagine your friend Billy is standing still in the middle of a long hallway. In this hallway, there are two flash bulbs, one on the left wall and one on the right wall. Suddenly, both bulbs flash at the same time. Because Billy is standing in the middle, the light from both flashes travels toward him at the same speed. He receives the light from both flashes at the same time and naturally concludes the flashes happened at the same time. But let's say you, being the jock that you are jogging through the hallway from left to right. Right when you pass by Billy, the flashes go off. Now you might think that since you and Billy are right next to each other at that moment, you should also see the flashes at the same time. But you don't. Instead, you see the light from the right flash first and then the left flash. It's as if, in your reality, the right flash actually happened before the left one. But how can that be? This happens because of Einstein's theory of special relativity, which states that the speed of light is always constant for all observers, no matter how fast they're moving. So even though you are running toward the right flash and away from the left flash, the speed of the light reaching you does not change. It still travels at the same speed in both directions. But for that to remain true, the only possible explanation is that the right flash actually happened first in your reality, giving the light from the flash a head start before the left one even happened. This might sound bizarre, but it reveals a deeper truth. When you move, you don't just change where you are, you change what you consider to be happening right now. Now let's take this concept and scale it up to something massive, millions of light years across. Imagine it's nighttime, and you're standing still in an open field gazing up at the Andromeda galaxy, the closest galaxy to us at a distance of about 2.5 million light years. As you look up, someone else walks by you in the field, moving in the direction of Andromeda. Even though you are both in the same place at the same time looking at the same galaxy, the events you consider to be happening right now in the Andromeda galaxy are different by days. Why? Because just like in the hallway example, your motion shifts what you consider to be happening at this very moment. If you are walking toward Andromeda, your simultaneity line tilts forward, meaning you consider some future event like an alien civilization launching a spaceship to be happening right now in Andromeda. But if you are walking away from Andromeda, your simultaneity line tilts backwards, meaning you consider that same event to be happening farther in the past instead. This is known as the Andromeda paradox, and it reveals an unsettling truth. Time is not universal. The concept of now does not stretch across the universe in a single absolute way. Instead, now is only applicable to here, and we intuitively extend it to things around, and that kind of works while discrepancies remain too small to notice, but on a larger scale, now doesn't mean what we're used to. It loses its meaning.